maximizing your mesh network. I'm Tonya Hall, and joining me is Nick Kucharewski, Vice President and General Manager for Wireless Infrastructure and Networking at Qualcomm. Welcome, Nick.
Hi, Tanya. Thanks for having me.
So, how are you involved with Wi-Fi products at Qualcomm?
So I manage wireless infrastructure and networking at Qualcomm, and we're responsible for chipsets and software for wireless LAN access points, including home networks, enterprise, as well as service providers.
What's the concept behind mesh Wi-Fi, and in what settings does mesh really perform best?
So mesh Wi-Fi was developed around 5 years ago. And the concept was to step beyond a single access point in the home for wireless connectivity to move to a mesh of devices. Those would self-organize to provide the fastest path through your network. And with that approach, you could get better connectivity at high bandwidth for all of the devices within the home.
What causes dead spots in Wi-Fi coverage at home or maybe in small offices, and what steps can we take to minimize or even eliminate them?
Yes, so the concept of the dead spot is generally driven by one of two concepts. One is range, where you're simply too far away from the nearest element of the Wi-Fi mesh. The other is from reflections, where you might be close, although there are a number of obstructions between the device and the Wi-Fi network. In both cases, this is really solved with a Wi-Fi mesh network. The concept is because you have multiple mesh nodes, you can place those devices in locations that would be closest to the devices that are using them. That way you have close range, high bandwidth, and low latency for the devices where they need it.
Product design often involves a tangle of trade-offs. In seeking to minimize dead spots, will I have to make any trade-offs related to security, bandwidth, or other important network performance or areas?
Yeah, so there are a number of considerations. One of the key ones is bandwidth, where you're looking at applications in the home, for instance, streaming television or video conferencing. You may have a large number of devices which are simultaneously connected at high speeds. And because of the nature of the application, namely video, there's a requirement for good responsiveness that gives you that lifelike experience. That means low latency. So in the design of both the Wi-Fi equipment and also the network, it's really important to make sure that you have sufficient bandwidth for more throughput, but also low latency. The third element is handling a large number of devices. As homes move from having maybe 5 devices to 10, 20, or even more, you now see slower speed devices such as home automation, light switches, and things like this connected over Wi-Fi. And those need to interoperate with the rest of the network. So there it's about, can you handle a large number of simultaneously connected devices while providing good throughput and latency for those high bandwidth applications?
As dwelling units and neighborhoods become denser and everyone has super capable Wi-Fi, what does that do to my ability to stay connected to my network?
So you bring up a really good point. So as we see more and more households adopt Wi-Fi, you start to see a concept of neighboring Wi-Fi networks interact with your Wi-Fi network. There are a number of ways to handle this. For instance, through advanced standards and also through features in the equipment, you can allow the devices to interoperate better with your neighboring networks to make sure that you have connectivity where you need it and you're not interfering with the neighboring network. For instance, Wi-Fi 6 includes a specific feature that allows you to detect the presence of neighboring networks and then adjust the transmit power for your device to make sure that you're able to continue transmitting, but not at a level that's so high that it might interoperate or interfere with that neighboring network. So there's a number of strategies for handling this concept of increased congestion of neighboring networks.
Wi-Fi 6 products are starting to appear in quantity. Is there anything designed to Wi-Fi 6 that improves coverage or signal strength?
So there's a number of elements for Wi-Fi 6, specifically around around signal strength and coverage. So one of those elements is has to do with the wider bandwidth of the channel. In this case, you can enable high bandwidth connectivity if you're very close to the device, but even as you get farther away from the network, you continue to have a fairly high-speed connection. What that means is not only peak performance when you're nearby, but also getting good performance as you get farther and farther away from the networking equipment. That's just one example of an enhancement in Wi-Fi 6, specifically around 160 megahertz and higher bandwidth channels that enables better performance for devices placed further away.
What sort of features should I look for in my next mesh router?
So there's a couple of elements. The first is to focus on the number of simultaneously connected devices. As I mentioned, this is a trend that we're seeing more and more in homes throughout the world, where you have not only high bandwidth devices, but also slower speed devices like IoT. And this requires the mesh equipment to be able to handle a high number of simultaneously connected clients. The second element that we'll increasingly see in 2021 is a new standard called Wi-Fi 6E. This is a brand new capability which enables a third frequency band of operation. In the past, we had 2.4 gigahertz and 5 gigahertz, and now we're adding 6 gigahertz. This gives you a lot more available spectrum to devices to enable them to operate at high speeds and at low latency without congesting the rest of the network.
Is Wi-Fi 6 mature enough that I should buy into the standard and future-proof my new equipment purchases?
Absolutely. We have seen Wi-Fi 6 devices on the market for almost 2 years now. And standards-based WFA compliant devices have been shipping for about a year, to the point where we now see a broad set of products available in the market that are robust, that have been proven out, that have tested interoperability among them. So Wi-Fi 6 is very much ready for the next generation of deployment within your home.
Nick Kucharewski, Vice President and General Manager for Wireless Infrastructure at Qualcomm. Thanks so much for your time, Nick, and shedding some light on this. If somebody wants to connect with you, what's the best way they can do that?
The best way to connect is through LinkedIn, where you can look up my name, Nick Kucharewski. Thank you very much.
Absolutely. And find more of my interviews right here or at tonyahall.net. Thanks for watching.